Hey guys, hope you are doing well. In today's video we shall look at covalent bond. In the last video we looked at ionic bonding, and we started from the definition of what is a bond in terms of chemistry. We defined a bond as a chemical union between atoms, and we looked at the three types of bonds, that is was the ionic, the covalent, and the metallic bond. But in the first video we made a detailed explanation on the ionic bonding. Now in today's video we shall mainly look at covalent bonding. Now in covalent bonding, in the ionic bonding, if you remember very well, and if you didn't see the video, I'll put a link in my description. So in covalent bonding we are going to deal with the sharing of electrons. In ionic bonding, remember, we looked at losing of electrons, a metal losing its electron to a non-metal. But here in covalent bonding there won't be any losing of electrons. Rather, we shall only find sharing of electrons. Now in definition, now at least you have got a hint on what we are going to do in covalent bonding. So in covalent bonding, this is the type of bonding formed from the sharing of valence electrons between nanometals in order to obtain a noble gas structure. So that is the definition. So in here we shall only look at sharing. Now I also explained about the valence electrons. The valence electrons are those that are found on the outermost shell of an element. So for instance, this is what I mean. So you need to understand valence electrons. For instance, if I have let me say, if I have like chlorine, so this is the symbol of chlorine. So if I have chlorine, remember chlorine, we looked at its electron configuration, electronic. It has a 2 to ratio 8 to ratio 1. So these values, all these digits, represent the shells. That the first shell has 2, the second shell has 8 electrons, and the last one has 1 electron. So these are the structures. Here you can do it. First shell, second shell, and the third shell. For the first shell you have a maximum of 2 electrons. Now I won't go in deep, but what I want you to understand, that we have for the electron, for the electron configuration of chlorine, it is 2 to 8, 7. So this should be 7. I'm sorry for that. So when you are feeling the third shell, that is the outermost. This is the outermost shell. This one, the last one, it is the outermost shell. So it is the one with the electrons, the valence electrons. The last shell is the shell that contains the valence electrons. So in here we have 7 electrons, 7 of them. Those are 4, those are 6, and these are 1. So these ones are the valence electrons, VE. So I think you have understood what do I mean when I say valence electrons. So are those electrons located in the outermost shell of the structure of an element or of a gaseous element. So I think you have understood what valence electrons are. Now another thing you should know in covalent bonding. Covalent bonding, it is subdivided into 3 types. Covalent bonding, it is subdivided into three types, namely we have single covalent bonding, single covalent bonding. The second one, it is double covalent bonding, and lastly we have the triple covalent bonding. So these are the types of bonding we shall look at. So this is the first one. Remember, these are subtopics of covalent bonding. The last one is the triple covalent bonding. So our main aim, we shall first look at we are going to look at both of them. So for the first one we have the single covalent bonding. So as you hear the word single, so in single covalent bonding, its definition is also simple. So in here, only one pair of electrons, as you hear single, so I'm meaning one. So it will have a one pair of electrons shared between 2 atoms. So here one pair of electrons will be shared between atoms. And what you should know in here, when we are dealing with single covalent bonding, you have to understand that only one pair of electrons will be shared. So in here, what you should consider, one of the things I also did, you must consider the valence, because when you consider the valence will give you the number of electrons that are going to be shared. Remember, when you know the valence, you know the ions, you know the electrons, the elements will either lose, gain, or share. So in here, this is what I'm going to tell you. In single covalent bonding, only one pair of electrons will be shared. Let us understand this. Let us take for example hydrogen molecule. So what you should know that first, why I told you that the valence is more helpful here, because why? Hydrogen, if you look at hydrogen, hydrogen has one valence electron. That means in its outermost shell, hydrogen only has one valence electron. I think we have looked at a video on how to get the valence of an electron, and I will also put a link in my description. So hydrogen has one valence electron. Now what will happen? Remember now I have two hydrogen atoms, because this H2 you are seeing here, this H2 means that hydrogen, they are two in number, so hydrogen is a diatomic element. So those are molecules that cannot exist on their own, but they exist in form of a group. So that group is referred to as a molecule. So here we are dealing with two hydrogen atoms, but remember, one hydrogen atom has one valence electron. So now, how to overcome or how to draw the structure of these two hydrogen atoms to indicate their sharing of electrons? So this is what you will do. This is what you will do. So we have understood that one hydrogen has one valence electron, but remember we are dealing with two hydrogen atoms because it is in form of a molecule, so it is also one. Now what will happen? Just draw the structure. Just draw the structure of the first hydrogen and then the structure of the second hydrogen atom. So this one has only one valence electron, and also this one has only one valence electron. Now under covalent bonding, what they will form, they will come together. These two hydrogen atoms, they will come together, but they will share that valence electron. How? They will be drawn like this, and then they will come in contact. Now when they come in contact, each of them will share its electron. That one is for the first hydrogen, and this one is for the next hydrogen. Remember, now they are sharing these two electrons. These two electrons, this will mean that this first hydrogen atom will have two electrons, and this one will also have two electrons. So since they are sharing this, they will have equal number of electrons, meaning that, remember that one of the things we looked at, the noble gases, they have having a structure of a noble gases, you should have at least a maximum of two electrons in your first shell. Now these two shells now have similar electrons in their shells, so these two shells are said to be stable, because since they are sharing, one at the end will have this, will have two, and the next one will also have two. So they are said to be stable because they have now contained the electrons required in a shell to be called an noble gas structure electronic configuration. So what you should know, I think I've understood there. So what you should know, that for a single bond to occur, the atoms present should have one valence electrons. So some of the another example, some of e.g. for instance, we had hydrogen and we have seen in detail. Now the second one, we have chlorine. So I think these are we have chlorine, and then the other one, I think those are enough. So that's what you should know. Now I think the other one can be fluorine, because we are dealing with nonmetals, the other one can be iodine. So you can try these, you can try out these examples and you will see what you will get. Any difficulty you may find in carrying out these examples in their structures to identify their single bond of covalently, I may comment in the comment section and see how I can help you. Now our next aim, it is the double bond. The double bond. A double bond. So here two pairs of valence electrons are shared. So in the single bond we looked at only two. We looked at only one. So these ones are two. These ones are two pairs. In the single bond we only looked at one pair. So in here we shall look at two pairs. So here what you should know that the atom that is going to be used will share two electrons. So those two electrons are the one that will be formed in a covalent bond, or that will be shared among the two atoms that will be present. In the single we look at only one pair that will be shared. Now here we shall have two pairs, and here what the component you will need to form a double bond, you will need an atom with two valence. So an atom with two valence, we looked at how to determine the valence of electrons. So e.g., let's take, for instance, let's take oxygen. So oxygen has a formula of O2. Has a formula of O2. So has a formula of O2. Now what will happen? Now this is what you should know, that oxygen has valence of 2. So has a valence of 2, but remember we are dealing with two oxygen atoms, because oxygen also exists in terms of a molecule. So here we shall have two oxygen atoms. It has an electronic configuration of 2 to ratio 6. It has an electronic configuration of 2 to ratio 6. Now let us look at the double bond. How will it be formed? So in terms of the double bond, remember we are having two oxygen atoms, but each with two valence electrons. So it has to with the electronic configuration of 2 to ratio 6. Now this is the structure. So it means that for oxygen it has two shells, one with the 6 electrons and the last one with the 1 with 2 electrons and the last one with 6 electrons. So this is it. Now for this one also, this is it, and this is it. So what will happen? In the first one we have 2, and the last one we have 6 electrons. The same also applies here. Same applies here. Same applies here. Now what will happen to these two oxygen atoms? This is what will happen. So these two, remember we have looked at their structure in terms of their electronic configuration. Now these two will share these two valence electron, each of them, but remember in their outermost shell they have 6 valence electrons. Now this is what will happen. This first oxygen will share these two electrons. The first oxygen now, and the last oxygen will also give us 2. That means how many electrons are left in the valence electron? How many are they? They are, in the first one, remember, like we removed only 2 from the 6, so we remained with 4. That is the same case with the second oxygen atom. So if you break this valence structure you have formed, you will have a maximum of 8 electrons in each atom, indicating that one of the laws we looked at for any structure to be called a noble one, it should have a maximum of 2 or 8. Now these structures now have 8 electrons in their outermost shell. In bonding, remember you consider the structure in the outermost shell, because we may ask that now where have we indicated the first structure, for instance this one with 2 electrons. So this is not considered under bonding. We only consider the structure that is the last one, this one, because it is the one containing the valence electrons. Now if you count for this structure, it has 8 electrons, but remember it also shares these electrons with this one, so this one also has 80 electrons if you count it very carefully. So with that, I think we are now done with the double bonding. So in double bonding, if you want to understand it better, here you need an atom with two valence. So that is what you should know, what you should need. But here remember we are dealing with just atoms of the same kind. But in the other video, if you would like also to do it, I may do a video when they are different compounds but they also form single, double or triple bonds. I can also make that video, but for this case let us first understand what do we understand by a single, a double and a triple bond. Now with that done, let us head up to triple bond. Let us head to triple bond. So we have looked at the single, the double, and then we are finally looking at the triple bond. So for the triple bond, here you need here three pairs of electrons will be shared. And the example here we are going to use it is nitrogen molecule. nitrogen molecule, and this is its symbol. It is capital N with a 2. So it is N2. This N2, I mean a diatomic element. So if you want more on how to understand these diatomic elements, you might comment in the comment section, and I will be happy to make a video about them so that you can understand them very well. So this is what happens. So nitrogen has 3 valence. Has a valence of 3. Remember that it has an electronic configuration of 2 to ratio 5. But you have to understand that nitrogen has 3 valence. That means nitrogen will share 3 valence. Why do I always indicate this electronic configuration? Because we need it in the structure of forming this bond. It helps us to bring the idea, what are we really talking about? Can we put it in action? So nitrogen has 3 valence, but remember we are dealing with 2 nitrogen atoms. This N2 you are seeing, it means 2 nitrogen atoms. So nitrogen, it is also the atomic element. As I told you, the atomic elements are those that cannot exist on their own, but they exist in form of a molecule. So that is a molecule. A molecule is a group of 2 atoms. That is a molecule. So let us understand very well also for the triple bond. So we have nitrogen. So we have nitrogen with a valence of 3 and an electronic configuration of 2 to 5. But also remember, they are 2. They are 2 nitrogen atoms. So this one also has a 3. So they resemble everything. They resemble, so they don't change. They resemble everything with the electronic configuration, the valence, the symbol, all of them. So this electronic configuration will aid us in drawing the structure. So the structure will look like this: the first shell and the second shell. Also the same to this, the same to this. The first shell is complete with 2 electrons. Also this. The second shell has 5 electrons, as you are seeing in this configuration. I'm using an electron configuration in form of ratios. I made a video on the electron configuration, and if you want to learn more, put a link in the description. So this is what we are talking about. So this is what will happen. Remember, we have found that nitrogen has 3 valence. So those 3 valence are the one that will be shared. So that means we are considering the outermost shell, but have understood that nitrogen has 3 valence. So from the 5 valence electrons in the outermost shell, we shall remove 3. 3 will go in the box of sharing. So this is what I'm meaning. This is what I'm meaning. I'm sorry, I have done it very long. It will confuse you. I want to draw it very well. I don't want these things to confuse you guys. So let me do like this. Now this is what will happen. Remember, from the 5 valence electrons, we are going to remove 3. That means in the outermost shell we shall have only 2 for this atom and also for this atom. Now in the in between, or this interregion structure, we shall have the first nitrogen atom to give 3 electrons, and the second will also provide 3 electrons. Second will also provide 3 electrons. So that is it. So if you count with these ones, So these are 8 in the inter region, and these ones are 2. If you add them, they also give you 8. So at the end we shall have this structure and this structure. After bonding, because after bonding they have now because all of them they share these electrons. The inter ones, they share these electrons, which are the inner ones. This one shares them, and this one also shares them. So each of them has now 8 electrons, 8 electrons in the outermost shell. So they are now considered to be stable. So having understood that, so what you should know about the triple bond, you need an atom with the 3 valence. That's what you need. But these were just atoms of the same kind. But if you want to understand atoms of different kind, just because of the time, I may stop here in the video. But if you want the atoms of the same kind, please comment in the comment section. No, atoms of different kinds in terms of forming their bond, please comment in the comment section, and I'll be grateful to help you around. My videos may be a little long, but I just want you to understand, guys. Just want you to understand. Please bear with me. Like, subscribe, and comment, and please share for more, and I will be happy to make more videos so that you can understand chemistry. So I have an activity at the end. I have an activity. I would like you to try it out. And I will be happy to help you. Please comment in the comment section by giving your answers, and I will be happy to confirm if your answer is correct. If your answer is correct or wrong. So this is it. So this is the question. So the electron arrangement of atom P is 2, 8, 6, and atom Q has 4 valence. Electrons. What is the formula? What is the formula of the compound? Formed between P and Q. P and Q. So this is the question. I want you to do it. Thank you very much. Hope to see you in the next video. In the next video, we shall mainly tackle on metallic bonding. Thank you very much. Bye.